Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, I'm Agus Ulinuha from the Department of Electrical Engineering, and for this opportunity, I would like to present my paper entitled Design and Implementation of Data Acquisition Device and Instrumentation based on Microcontroller for Electric Motorcycle. Let me share the screen. This is the title of my paper, and I composed this paper with my colleague Jatmiko and my student Almas Gulam Risa. Okay, this is the background of the paper. Intensive people activities lead to increase of transportation demand. Due to road density, motorcycle will be the best choice. It's the better choice because it can move in a flexible way. However, motorcycle causes severe air pollution and high fuel consumption. Therefore, electric motorcycle will be the answer for this problem. Unfortunately, electric motorcycle depends on battery for energy supply. And the problem is the battery takes time to recharge. Yeah, it takes some time to recharge. It can be instantly recharged. Therefore, optimal battery use will be one of the solution. And this might be assisted with instrumentation system. Why? Because the instrumentation system will present information of real-time system operating condition that can be used by the driver to know, yeah, system operating condition including the battery capacity. Okay. For this purpose, we developed a system. It was actually a motorcycle powered by internal combustion engine. And we replaced with PLDC 1 kilowatt, 36 volt, 48 volt, yeah, as a prime mover. Yeah, as a prime mover. And this motor is supplied by lithium ion 48 volt, 17.5 ampere hour battery. And for charging, this motor is equipped with a charger of 48 volt 2 amps. And this is the instrumentation system, as we can see, yeah, the front side of the motorcycle. It uses some sensor and processor. And when it is installed in the motor, it is how it look like. Yeah. This is the block diagram. Okay. Some sensors are used in the system to read some parameters, yeah, to read some data about real operating condition of the motorcycle. And these data are supplied to the processor, Arduino. And the result are displayed in a TFT display, or it is saved in memory. Yeah, this is just the explanation for the block. Okay, this is an example about the magnetic sensor installed in the motor. Yeah, in the motor. For data acquisition, sensor read data like current, voltage, and etc. depending on the need. Yeah, and For voltage sensor, it uses voltage divider to reduce the voltage source into 5 volt because Arduino accept the maximum voltage of 5 volt. For current sensor, magnetic field is generated when current flowing through the sensor, and the whole IC on module will convert into proportional voltage. Hall sensor or magnet sensor detects magnetic field and responds with the voltage proportional to the magnetic field. All sensor send the data to Arduino and it processes the data and display them into TFT or save into the memory. The data are saved on SD card module using RTC or real-time clock, and it is equipped with battery. So in case that the motorcycle is switched off, the data will not be lost. Okay. This is the instrumentation main board, yeah, rear and front view. And it is when it is installed, yeah, in the motorcycle. It uses 3.5-inch TFT. Now for benchmarking, yeah, we measure the RPM using sensor and benchmark the data with those given by tachometer. And we can see the result. It is close enough. Even some deviation are detected. The average deviation is 5.8 with the maximum deviation of 18 RPM. For the speed, this is the measurement result, and again we benchmark with those given by Tacho. And as we can see that it is close enough as well with the average deviation, yeah, from the measurement given by a sensor and the measurement given by Tacho. Yeah, and the average deviation is 0.558, 0.556 kilometer per hour, with the maximum is 1.73 kilometer per hour. This is the complete test data. Yeah. Okay, as we can see, this is the measurement. Yeah. And for every data, the corresponding data are also given. For example, for this RPM, we got what's the voltage, current, and etc. Yeah. So it's complete enough, I think. As a conclusion, the developed instrumentation system might work properly, displaying the useful data or information for driving needs. The data or information displayed in TFT, yeah, are sufficiently accurate based on benchmarking, yeah, for the measured data given by the sensor to those given by measurement device. Yeah. And because of that, it is expected that this instrumentation system may be used for this electric motorcycle or can be extensively used for the similar system. That's all my presentation. Thank you very much for your attention. Assalamualaikum warahmatullahi wabarakatuh.